Okay, so let's look at those ones you worked on by yourselves. Yeah, Matthew, did you work on them? I see they're blank there. What's the story? Well, honey, one isn't enough.
Can we go over G?
All right, let's go through these. So I hope the first thing you did was divide by 17.
I did that one.
93 and 17 don't divide, so we're just going to leave it alone. Now, we know we got to get the exponent off of, it can't be an exponent. We got to get that down. So the only way to make that happen is to take a logarithm. Since there's an e in the problem, we'll use ln, because an ln and an e will always cancel each other out. So x equals ln 93/17. So you should have gotten, for this problem, whichever one this one is, you should have gotten as your answer 1.6994.
Yeah.
You get that? Now, the next one looks a lot more complicated, but it really isn't.
You just end up getting the 1.112 with the x and then you add it over.
Divided over.
Yeah.
Yeah. So first, though, we're going to divide by 50. Now, you don't know this yet because you haven't done these before, but these problems are prepping you for the word problems we're going to be doing shortly, where you're going to be writing equations and they're going to look like this. The equations you write, believe it or not, are going to look like this, and you're going to have to solve. Okay? So we divide both sides by the extra number. Always get rid of that extra number, so it's done, it's gone. Now, because there's an e in the problem, I won't log, I will la. Now, if you log'd, you could still get the right answer, it will just take more steps. These will cancel, negative 0.112x equals ln 4. So x equals whatever ln 4 is, divided by negative 0.112. And again, make sure you are closing your parentheses when you take a logarithm of any kind, ln or otherwise. Did you get negative 12.3776? All right, now let's divide both sides by 3. Leave the fraction. Now what? ln both sides. Those cancel. 0.17x equals ln 19/3. So we're going to type into our calculator ln 19/3 divided by 0.17. And whoops, what did you say you got?
10.8578.
10.8578. 8578. Perfect. Perfect. All right, so you told me they were hard, so I did them all and you didn't pay any attention.
I know, I'm sorry.
Yeah. Okay, we got that figured out. Everybody feeling okay about that? All right, let's.
Keep going.
Yeah,
I want you to keep going. It's his request.
We got more to learn here, and I think we can do it. And then I'll put together a review for next time to kind of go back and look at all the different kinds of problems we've done. All right, let's look at number 4A here. This looks terrible. So let's see if we can figure out what to do. Are we all paying attention? This is a big scary problem. So let's talk about what?
You get rid of the 3.
We get rid of the 3. That sounds like an absolute magnificent idea. So if I do that, I will be left with this.
And divide by 2.
Negative 2. So then I am left with this.
And then do your loop or whatever.
Yes, very good. When we get to this point right here, you can't solve this with this logarithm sitting in here. So how do you get rid of the logarithm? You loop-de-loo it. So 6 to the negative first equals x plus 2. Right?
1 over 6.
What's 6 to the negative first?
1 over 6.
1 6 equals x plus 2. So now we're going to subtract 2. Okay, so you have 1 6 minus 2. Okay, if we don't want a decimal, so if you could get a common denominator, so that would be 1 minus 12, so negative 11 6. Now, if you wanted to use your calculator, you could. So those of you that have one and want to use it, go ahead and do 1 6 minus 2, and you get a decimal, right? Now make that a fraction. So if you're using the graphing calculator like you're supposed to be using, you're going to hit math, and then enter, and sometimes twice enter, and it should say negative 11 6. So if you need to use a calculator, and this is a calculator section, which it wouldn't need to be, but if it happened to be, you can do that. But I don't want some rounded off answer when you can get a nice neat fraction. All right, how about B?
Divide by 3.
I probably wouldn't divide by 3 first. I would probably add 2. And then, no, it would be in parentheses if it were. Okay, Jalen, it would look like this. Okay? All right, so I'm going to add that 2. Now I'll divide. So ln x equals 2. This means log base e. That's what ln means. So can we loop-de-loo? So our answer, e to the second equals x. Now we ran into something like this a couple days ago, and we talked about if this is a no calculator thing, then you're going to stop right there. If you want a decimal, like if it's part of a word problem and you want a decimal, you can type that in on your calculator. Where did we find e? Second ln, and then to the second.
7.38.
So 7 point something if you wanted a decimal.
So we can just leave it like that?
Yes, definitely leave it like that. All right, will you try C on your own? See if you can get C.
Yeah, I'm confused.
Uh-oh, we're confused already?
How do you get a negative log?
Well, it's in the problem.
Just a negative 1 log.
It's a negative 1, isn't it?
So, yeah, that's like a negative 1, right? So, what will I do first?
Subtract 2.
Subtract the 2.
Divide.
So I have negative 1 log x plus 1 equals 2.
You can move to no, because the base is 10.
Let's get rid of that. Can we divide both sides by negative?
Yeah.
So log x plus 1 equals negative 2.
No, it's
What's the base on this? 10. So as soon as you recognize your base is 10, you can loop-de-loo it. So 10 to the negative second equals x plus 1. Here we go. What's 10 to the negative second?
110, or 1/100.
1/100. So x is going to equal 1/100 minus 1.
1/100.
Be careful. It's 1/100 minus 100 hundredths. Negative 99 100ths. You okay? All right, let's try the next one. See if you can, how far you can get with the next one. It's a little easier, actually. Can you solve for x, Magnus? Step 1. Divide by 5. Good plan. Step 2. Add 10.
Loop de loop, because the
Oh,
base is 10.
Put the 10 in?
Yeah.
Yeah, because LOG means base 10.
And then 10 to the 2.
10 to the 2 equals 2x.
Then you get 100 equals 2x.
So 100 equals 2x and x equals 50. Come on, are you getting the hang of that?
Yes.
Yeah, those aren't bad at all. Let's try the next one. Okay,
Divide by
we're
3.
solving this one. Let's not divide by 3 first.
Subtract 1.
Let's subtract the 1. Oops, subtract the 1.
Divide by 3.
Then divide by 3.
And then look
2 over 2 equals x.
2 to the second equals x, so x equals 4.
add 3.
Yep, I'm not caught up yet. You're getting too fast for me. Oh my, is that right?
Yeah.
Okay, now what?
Divide by 2.
Divide by 2.
Add 3.
And then, yeah.
So 3 to the 3.5 equals x.
Is that a calculator problem?
That's a calculator problem, unless we're just gonna leave it like that. Because,
Do you still have to put 4 decimal points?
yep,
42.875. Doesn't give us the 4.
so did you say 46.7654?
What?
That is number E, letter E. Oh, that was that. Oh, that was that. I'm
Couldn't you
sorry.
divide by 2 and then add
That was
the
that.
3 for F?
For F, I added 3.
I know, but couldn't you divide by 2 first and then add 3?
You can, but when you divide by 2, you have to divide by 3 also. You have to divide everything by 2. All right. What's the difference here? These look like the same kind of problems.
You just have something to go along with the x.
Yeah, yeah. So we're gonna do just a couple from this section. These are, A is easy. A you got. B is a little bit harder. So we're gonna do A and B, and then we'll stop, for the day. So we're gonna do A and B. Now, A is easy. You already know how to do this one. You just did some. What are you gonna do?
Loop-de-loop.
Loop-de-loop. Boys and girls, see how these things are in a parentheses? That means you can't be subtracting 7 You can't be dividing by 5. It's not like over here where the numbers were outside, so you could go ahead and divide, that wasn't a problem. Here you can't do that, you go straight to loop-de-loop. So 3 to the second equals 5x plus 7. 9 equals 5x plus 7. 2 equals 5x, and x equals 2/5. Okay? Now, the next one is different. What is different about B? This is the last problem we're doing today. There's 2 logs.
You combine the logs.
Yes. Now, listen, this is one of the things I wanted to review because we did it a long time ago. You cannot solve an equation that has more than one logarithm on each side. Okay, not possible. So what you need to do is somehow condense these 2 into 1. Now, we talked about this the other day. Since these guys are being added, when I put them together and make one logarithm out of them, I'll change that addition into a multiplication. Remember? One of our properties says log mn equals log m plus log n. Remember that property? I may have used different letters, but so when you take these 2 and mush them together, it becomes a product.
Log x squared plus.
So this is going to be x squared minus 3x.
And then we
So, do you want us to, instead of putting x into?
Well, at some point, I don't care if you want to put another step in there, but at some point they have to be times together. Because we're going to solve this thing. So now we know it's a base 10. So 10 to the first equals x squared minus 3x. Oh no.
And then say equal to 0.
Yes. Very good. This is a quadratic equation.
So you have to solve with the.
X minus.
So we can factor it, complete the square, quadratic formula, whatever flips your switch. Does that factor?
X minus 5x plus 2.
That's a check extra, yes.
Oh, yes! So wonderful, Emma! So wonderful, because we discovered the very first day we took out our calculators and we tried to type log of a negative number. Do you remember what happened?
It doesn't
It
work.
doesn't work. So if I were to let x be negative 2 and put it right here, would that work? So that is an extraneous root. Very good, Emma. We have ended on a high note. All right. For next time, which I don't know when that is, I'll have some kind of review thing put together so we can catch up before we go ahead. Next time, we will be starting our word problems.
Oh,
Yep, everybody needs a graphing calculator.
Make sure to buy one that day.
Have a good day.
Me too, Mr. Ford. Feel better?
Do you have any
I hope
notes?
you feel better.
Well, actually, I did kind of have dry measles, and I do feel better. And then Emma came up with extraneous roots, so